Hi, Lori here to walk you through how to do the regressions for the Titanic homework. So this is a database that we picked up, I think, from Kaggle. And one of the things we're going to want to do in order to use this database is to convert sex from being a descriptor, male and female, or a category, into being a dummy variable, which means we assign a number to each value. And in order to do that, we're going to have to insert a column right there, and we're going to use VLOOKUP, which many of you will fondly remember. So we're going to look up the male value. Oops, we better give ourselves a little array here, huh? Male, female. I'm going to make men number 1 and female number 2. You can use 0 or 1. You can reverse the order if you want. It's just important to remember what you assign to each number. So we'll go back to our VLOOKUP, and we'll look up male, comma. We'll go look in this array, comma. We'll want to use the second column, and false. That looks great. Now we're going to go back and anchor our array. Let's see if we can make it stop beeping at us. There we go. Great. And now we should be able to double click on that and everything moves down, and female is 2. We'll just spot check. Yep, that looks good. Now remember, this is a formula and we don't want it to be a formula. We'll go ahead and we want it to be a value. So we're going to copy it and paste it as a value. That way if we were to get rid of this column, we'd be all set. Now it says that we want to work with survival as the dependent variable. That's the percentage who survived. Here's another dummy variable. 0 means they died and 1 means they survived. So that's another dummy variable that we will be using in this regression. We're going to run a single linear regression using survival as the DV and class. That's P class, class of service. This would be third class, this is first class, and we've got a second class one here. And third class is lower cabins, and they're not quite so nice. And first class, people paid a lot more for those tickets, and they had nicer cabins, usually up a little bit higher in the stacking of the decks on the boat. All right, so we're going to go ahead and predict survival based on class. So we're going to go to our data, analysis, regression, and the thing we want to predict is survival. So we'll highlight first few of those, Control-Shift down, or Command-Shift down on a Mac, I believe. And what are we regressing? We're going to go back up, and our independent variable is class of service. I'm going to go ahead and do that. And we want to let them know that we have, Excel know that we have labels. We're going to do confidence level of 95%, and we want to get our residuals. Okay. Here's our printout. We're going to widen our columns. The first thing we're going to do is make sure that we have a model that works, that's significant, that just didn't happen by chance. And this is much lower than 0.05, our significance F, so we're all good there. We're predicting about 11.45% of the variation in the dependent variable, which is survival, using the independent variable, which was class. We're going to take a quick peek at our residuals by hitting Control-Shift down. We're going to go Insert. We're going to insert a little chart, a scatter plot. And it's a strange looking scatter plot, but they seem to be on either side. Okay, so I think we're all right there. All right, let's go back up to our data. And we've got a p-value, which we want to use our conditional formatting for. We're going to do less than 0.051, and we're going to make them green because that green means good to go, and both of them are below 0.051 or 0.05. Now your p-value for your intercept doesn't need to be below 0.05, but you do need it to be below 0.05 in order for an independent variable such as class to count as a variable that is affecting your R squared. And that's it. That's our very first one. The percentage of survival determined by class is right here at 11.45. The impact on class impact of class on the ability to survive or the likelihood of surviving was negative. It's a negative correlation. And what that means is that as class moved from first to second or second to third, your chances of surviving went down, unfortunately. But that does make some sense. All right, now we're going to go back in and we are going to do what is required next, which is sex and class. All right, so what we're going to do is pick up sex. Oh, let's go ahead and make a spot right here. Pick up sex, cut, paste it here. There we go. And it's a good thing that we did a good job making it a value there. And now we're going to do the same thing, which is do a regression, but it's going to be based on class and sex. So it's a multiple regression. We're going to go to data, data analysis, regression's already checked. We are still predicting survived, but instead of just using class, we are now going to use class and sex. So we highlight both of those, Control Shift down, pop back to our form. We've got labels, confidence level, and residuals. We're all set. Okay, let's go ahead and widen these. First thing we check is our F, significance of F. It's a very small number. It's e to the negative 89, so we're good. Let's go ahead and do some conditional formatting on our p-value. Use 0.051 and we'll make it green because that's good. Okay, both of them are less than 0.05. Both very small numbers, e to the negative 67 and e to the 22. So that's significant. We are predicting 36.8%, we're rounding, 36.8% of the variance or in the survival. And we're doing it with two variables, class, which is a negative correlation. As your class moved from first to second and second to third, your chances were, you were less likely to survive. Sex, as you move from 1 to 2, you're more likely to survive. And if you'll recall, 1 was male and 2 was female. So what that's telling us is that as we moved from male to female, we significantly increased our chances of surviving. And I'm going to go ahead and label these class and sex. And this one will be just class. That way, if we have to refer back to something, we can. All right, and then let's go ahead and do one more. And now we need to include age. So let's go ahead and insert a column. We're going to pick up age, cut, paste. Now you'll notice here some of these don't have a number in there. And we can't run a regression with nulls or non-entries. So we're going to have to get rid of those. And the best way to do that is to highlight all of our data and do a quick sort on it. So we're going to do data, sort, and we're going to sort by age. Whoops, we've got labels as headers, so we click that, and it'll give us a lot easier to work with. We'll go smallest to largest on age, and here we had somebody who was just under 6 months old. And then we go all the way down into the 30s, 40s, and let's see, 80s, yep. And then now we've run out. So from here down, we're going to go ahead and eliminate that data. We're going to go ahead and highlight it. We're going to right click, we're going to cut it, and we're going to throw it in an additional sheet. Just make a sheet, throw it in, and that will be data that we cut. Paste it. And I'll put in data that we cut. Now we've got a slightly smaller data set, only 714. We've 715 less the labels of 1. So we've got 714 data points. And we cut out, let's see, how many? Ooh, we lost a lot of data. We cut out 176. So it's a good thing that we ran class and sex first because we had more data points, and that's always good. You always want to use as much data as you can. So let's go ahead and run this regression on all three. So we're going to go to data, data analysis, regression. We're still predicting survival, so that's good. Our Y value is good. Here, we're going to want to pick up class, sex, and age. Highlight those and Control Shift down. There we go. Labels, confidence level looks good. We want it on a new worksheet, and we want to print the residuals. There we go. Let's see how Ooh, it must have the same number of rows or values. Let's see what's going on. Ah, this is because this was left over from the old regression that we did. So let's go ahead and reset that because we don't have 892 rows of data anymore. We only have 716, I believe. 715. Okay, now it should run. There it does. That's great. Now we're going to widen our columns. First thing we check is significance F, and it's a very tiny number, so we know that this model is working. We're predicting 39% of the variance in the survival rate, and we're doing it using class, sex, and age. Let's see if those p-values hold up for us on our independent variables, and we're going to give that a try at 0.051, making it green, and they're all green, which is good news. And what this tells us is, as we suspected from our prior regressions, class, going from first to second or third class, hurt your chances of surviving. In this particular case, if you were a female, then you had a higher chance of surviving. And here, the older you got, the less of a chance you had to survive. And that's pretty much what you need to get from this. Now, the cool thing is we can use this to predict. So I'm going to go ahead and copy this, and let's do some predictions. All right, so these are the variable inputs and what the impact will be. So intercept, we always put a 1 next to it. The class, we'll fill that in later. And the impact is the coefficient times the variable input. And you can just copy this right on down. And the total of all 4 of these numbers will equal our chances of surviving. So I'll go ahead and sum that. And if we were first class, and let's say we're a man, which is a 1, and our age is 45, then we had a 39% chance of surviving. However, if we were a female, same age, same class, we would have had an 87 or 88% chance of surviving. I think there were 4 questions that we had to answer for the questions on this, and the first one was a first class male passenger, age 25. So first class male passenger, age 25. There you go, 51%. What are the chances that a second class female passenger, age 25, would survive? So we're going to be in second class. We changed that. Female passenger, that's a 2. Age 25, much higher at 78%. What are the chances that a third class female passenger, so we're third class, female is 2, passenger age 50 would survive? And that would be about a 44% chance of survival. And finally, we've got a first class female. So first class, female is 2, age 22. And here you can see you're actually up over 100%. And that's because this is a predicted value that also includes an error term, and sometimes you can be a little bit off. There's always a little bit of wiggle room on these estimated values. So we would just simply put 100% there. And that's it for this video. Hope everybody's having a great day or night, and hang in there and keep working on these regressions. They'll get easier the more you do.